Let's review optimization. Optimization is a fancy word for finding absolute max and absolute min. This can be done graphically, it could be done within a word problem in applications to real life, or it could be done in just a function. So before we even look at a function, let's look at this topic graphically. So let's just think off to the side what a graph could look like. So if we think about maybe in our thought bubble here, if we think about maybe an x to the fourth function. So the way that these look is kind of like a W. So if we think about optimization graphically first, optimization means comparing critical numbers to endpoints or end behavior. So if we look at the critical number of this graph, first of all, there are three critical numbers. There's three places where I see soft peaks where the derivative would be 0. So we have here, the derivative would be 0. Here, the derivative is 0, and also here. Now, there are two steps to optimization. First step, locating all of the critical numbers. We just did that graphically. The second step is to compare it to the end points or the end behavior. So we want to compare our critical numbers and see, are these relative max and min also the absolute max or min? So first of all, if we look for absolute min, our three critical numbers, here, here, and here. Well, I do see a lowest critical number. It's down here. And I want to figure out, comparing that critical number to the endpoints, is it also the lowest, absolute lowest? It's a relative min, but is it also the absolute min? Well, my end behavior is up, up. So that relative min is also an absolute min. Now, same thing for finding absolute max. We would find all the critical numbers, we have those three, and compare them to the end behavior. Now, this critical number here is my relative max. And to see if it's also an absolute max, we look at the end behavior, which is up to the left and up to the right. So it's going to go up without bound. So there is no absolute max. So we have our two steps: locate the critical numbers, compare them to the endpoints if you're given some, or end behavior in general if you're not. And looking at this graph, we do have a relative min. We actually have two relative mins on this graph. These two relative mins switch from decreasing to increasing, and only one of them is absolute min. Then we look at our other critical number is a relative max, but comparing it to the endpoints, it is not an absolute max. So critical numbers give us our relative extrema, and then we compare them to the endpoints or end behavior if we're not on a specific interval to see if our relative extrema are also absolute extrema. So there's one with an absolute min, but no absolute max. Now we're going to do that without a picture. So looking here, we have a function. We're going to do the same thing we just did. It's going to be a little bit longer process to find those critical numbers than just looking at the graph. We're going to take the derivative of x cubed to be 3x squared. Derivative of negative 48x is negative 48. And we're going to set that equal to 0. We're going to find all critical numbers, whatever makes the first derivative 0. We could factor out a 3 from both of these. 3 times x squared minus 16. So we are going to try to factor this some more because we have x squared minus 16, which is a difference of two square numbers. So we have x and 4 being squared. So we have 3 times x plus 4, x minus 4, doing some factoring from algebra. Now these three things can only multiply to be 0 as long as at least one of the factors is 0. So we want to see, can we make the first factor 0? No. 3 is always 3. But can we make x plus 4 0? Yes. If x is negative 4. And can we make x minus 4 0? Yes, if x is positive 4. So we have two critical numbers, negative 4 and positive 4. But our second step is going to be comparing those critical numbers to our endpoints. We want to look on the interval of interest. So for this, it tells us to look from negative 2 to 10. So I'm going to plug in my endpoints and see if they're either highest or lowest points on the graph. So negative 2 and 10 with any critical numbers on the interval of interest. So if it's not on the interval we're interested in, it doesn't matter whether it's a max or a min. We're looking between -2 and 10. What's the highest point and what's the lowest point? So it could either be at our critical numbers, because our relative extrema at critical numbers could also be absolute extrema, or it could be at our end behavior. So looking at my two critical numbers, I have -4 and 4. Well, -4 is not on the interval. So I don't need to test that to see if it has the highest or lowest y value. It's not even on the interval we're interested in. It's like if we zoomed in on this graph here, we were told to look just from here to here, it wouldn't matter what was happening outside of there. It would say, well, what's the highest and lowest y value on that interval? Doesn't matter what's happening outside that interval. So we wouldn't test something not on our interval. So looking from -2 to 10, as we were asked to, means we are not going to test -4 because it's not on our interval. But we are going to test 4 because it is between -2 and 10. So if it gives us an absolute highest or lowest point, we do want to know. So now we're comparing y values, which means we're going to plug in where for y values. Do you plug into that original function or the derivative you just found? The original function gives you y values. So if you plug in f of -2, you get -2 cubed minus 48 times -2, which is 88. Plugging in 4 to that original function, 4 cubed minus 48 times 4 is -128. And then lastly, plugging in 10 cubed minus 48 times 10 is 520. So comparing these to find absolute max and absolute min, I'm just looking at y values. The highest y value between 88, -128, and 520 is this one here. So we would say the absolute max point is 10, 520. And then our absolute min point is either at that critical number or at the endpoint. So we're comparing 88 and -128. -128 is lower. So it's going to be at our critical number. There's our absolute max at 4, 520. And our absolute min is at 4, -128. So we're looking for all critical numbers and comparing them to the endpoints if they're given. If not, we're going to look at the overall end behavior. And we can do this graphically, without a graph, and also within a word problem. Same two steps. Critical numbers compared to the end behavior or end.